So today we're going to be doing rectangular approximation, but we're going to be doing it from tables. Okay, we've been doing it from functions for the last couple of days, and there's not much difference. Okay, where we did it with a function, we would actually create this table. Okay, basically this table represents what we've been doing with our functions, where these values here are my x values, and these are my y values. So it would have been like if we had done this, f of 0 equals 3. And we created our table basically going down. This one's just going across. So just to give you an idea, we're going to be finding the area under the curve using RRAM and 6 intervals for this given data. So one way of visualizing it is to graph the data. These are x and y values. So for instance, 0 and then 3. So 1, 2, 3. So this right here is a data point. Okay, 1, 2, 3, 1, 2, 3, 4. I guess I should actually do it this way, since I know that I'm going to be going up to 12. Do those by ones. Okay, so my next piece of data is 1, 1. Let's redo this. So 0, 1, 2, 3 is right here. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 10. Then 5, 10. Then 9, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 6. Like that. Then 10, 2. 12, 1, 2, 3, 4. Okay, so these are our data points. Okay, you with me so far? So basically, we're going to be doing RRAM with these 6 intervals. We're doing 6 intervals. We're splitting 12 up into 6 intervals, but we're not splitting it evenly. And that's going to be the hardest part about this, is we're not splitting this evenly. Okay, so think of it as each one of these is going to be kind of like a rectangle. So this is my first rectangle. This one is my second rectangle. This one is my third rectangle. This one is my fourth, fifth, and sixth. Okay? So if we're doing RRAM here, that means that from these two data points, my rectangle looks like this. My next two data points, rectangle looks like this. Then like this. Like that. Oh, I forgot all this. This is my x-axis. That wasn't down far enough. Sorry. So these are my rectangles. These are the areas. Okay. So for my first rectangle, for rectangle 1, what is my height? My height comes from the right side. So rectangle 1, the height is 9. So height is 9. What's the length of my base? From 0 to 1, that's 1. So my first area is 9. Rectangle 2 comes from the right side, 1 to 3. So rectangle 2, the height is 10. But this width is different. This width is 2, because from here to here, this is 2. Rectangle 3. From the right side, the height is 10. This distance, the width is 2. Rectangle 4. The height is 6 with a width of 4. Rectangle 5. Height of 2 with a width of 1. And our last one, rectangle 6, has a height of 4 with a width of 2. So we find all of these areas. So rectangle 2 has an area of 20, 3 is 20, sorry. Rectangle 4 is 24, 2, and 8. And then we add up all of these areas. So 40, 50, 60, 64, 74, 83. That is my area. Okay. So the difference is we're just getting our y values, our heights and our width from a table. Okay. Now I didn't necessarily need to graph it, but I wanted you guys to see how it would look if we graphed it. So you could technically see these areas. And you could really easily see this area right here. This one's 9, this one's 20, this one's 20, this area is 24, this area is 2, and this area is 8. You could even count up the little rectangles if you wanted to, and it would be that. Okay? So the main difference is that our widths are not all the same, so we can't just add up our heights and multiply by the common width. We had to find this one, each individual area first, and then add them all up.